Hey, this is going to be a video summarizing what we accomplished at the hackathon from a contributor perspective because the details are still relatively fresh in my mind one day later, and so I figured I better capture this now before I lose it all. I'll start off by showing you the extension running. So I'll run the extension with function F5 and then go into debug mode. And the first thing to point out is that we have a ClearML sessions sidebar item right here, and it has a refresh button. And if we click the refresh button, we should see our sessions. This is awesome. Okay, so the fact that we just saw our sessions shows that we are making authenticated requests from our TypeScript code to a ClearML backend control plane. So basically what we did is Jordan and I signed up for the SaaS version of ClearML, which is actually free. And I think when you get the free version, you can invite up to 2 collaborators to your ClearML workspace. So I signed up and I invited Jordan to my ClearML workspace. And then I went over to settings here and then workspace. And here I was able to create a set of credentials for ClearML, and I'm using these credentials to make authenticated API calls. So the way that I set this up, and Jordan did this too on his laptop, is I ran the pip install ClearML command, and then I did ClearML init. And when I did ClearML init, it asked me to copy paste the credentials that I got from the UI here, and then generated a config file for me in the Hocon file format. So it's a file format called HOCON, and it's a way that you can express configuration in a file, and it's different from JSON and YAML. So that ended up being a problem. And the reason why is I could not get a library in TypeScript to parse the Hocon file format. There were like 6 libraries out there, but 4 of them hadn't been updated in 4 years or more, and the other two, one looked decent. It was this pushcorn Hocon parser library. And what I liked about it is that they have this badge here saying that they're monitored by Sneak security. So I didn't validate that they're actually, so I didn't look much further into this, but I like the idea that the author's concerned about security, because whenever you add a dependency to a library, you're exposing yourself to security vulnerabilities. Like, it would suck if someone were hiding malware inside of this Hocon parser library, and then we included it in our VS Code extension and then published it to a whole bunch of people. So in theory, this library looks really well thought out, but I could not get it to work. It looks like they had planned for it to be a CLI tool with some library bindings inside of it for you to call a parse function on Hocon format, which would then turn it into a JSON object. And that sounds great, but I actually couldn't figure out how to get it to work in code because they don't have TypeScript bindings, which makes it really hard for a non-web developer like me to figure out how to get this to work because I didn't have auto-completion after I installed it. And also, I did try executing their CLI tool against the ClearML Hocon format file. It's called clearml.com, and it was not able to parse the ClearML file. It had some sort of parsing error, and I can't remember what it was. So it's possible that ClearML is doing something with their config file that is potentially non-standard, or maybe this Hocon parsing file isn't a full implementation of a Hocon parser. And so maybe there's some feature of Hocon that ClearML is using in their config file that this thing didn't get around to supporting, which would be a bummer because this looks like the most developed Hocon parser in the JavaScript world. Okay, that was a whole 4-hour venture for me during the hackathon, so I wanted to go into all of that detail. So basically, to make requests to ClearML in order to fill out this sidebar here, I ended up using regular expressions to grab 3 values out of the config file. And those values are, and I can show you them right now. I'll open up my ClearML conf file. This is what Hocon looks like. The values I wanted to grab are this API server value, which you could change to point at some other URL if you were hosting this in Docker Compose, for example. Although, as a side note, if you do that, you have to enable TLS encryption for your ClearML deployment so that you can have an HTTPS URL, or else I don't think you can actually use the ClearML SDK against your self-hosted version. So that's something to note. Okay, sorry for that distraction. So the 3 values that I wanted to grab out of this file are this API server URL, and then the access key and the secret key that we use when we make requests. Jordan and I found a ClearML REST API reference, which ended up being incredibly helpful. We went back and forth between trying to decide whether or not to use the ClearML SDK in Python to interact with the ClearML backend server, or just making those calls directly from TypeScript. And I think I am the one who made the decision to eventually just hit it in TypeScript. And the reason why is because if we did it in Python, then we'd have to have TypeScript executing a Python script and somehow finding a way to get the result of that Python script communicated back to the TypeScript program. And when you do that, debuggability and traceability starts to get compromised. And also the complexity of your application just goes up. So we opted to make these calls directly from TypeScript. And so before I keep going down this path, I'll let you lay eyes on some of that TypeScript code. In our source folder, in our extension, I made a folder called ClearML, and in here I made a file called API client. And I don't normally love classes, but I thought using a class for an API client made a lot of sense, and here's why. Basically, whenever you interact with ClearML, you have to authenticate with it first and get an auth token. And once you have that auth token, you need to pass that auth token. And once you have an auth token, you need to pass it along in the headers of every subsequent request you make. So I figured it'd be easier if we wrapped the auth token as state in this class. So I wrote an auth method, and I'm using the Axios library here to make requests. But funny thing with that, later on, the Axios library completely stopped working for me. And every single request that I made to ClearML, except for this auth request here, gave me a 401 unauthorized error. And so I actually had to switch from using Axios to the fetch library for my other requests. And so honestly, we should probably just remove all references to Axios and just use fetch for all these things, because for all intents and purposes, they're doing the same job for us. They're both just allowing us to make HTTP requests. Okay, anyway, so I have this auth method, and when we call it, it stores the resulting token on the class as an instance attribute. And I believe that's the only instance attribute on the entire class, except for the config, which is the API key, which is the credentials to be used to fetch this token. Okay. By the way, to get those credentials, I added a convenience factory method called fromConfigFile, and you can pass in a path to the config file. And that does the hard work of instantiating the class for you. And this fromConfigFile function calls this other function that I wrote, which parses the Hocon file using regex and grabs those 3 configuration values out of it. So of all the code in this, so I wouldn't say that the code in this project is in a very clean state at all right now, but especially the code you'll find in this function and down is pretty hacked together. Okay, so once we have our instance variable token, we can then call functions that make API calls to ClearML and have the authentication built in. So here's get project ID by name. This is something I made to search for the ID of a ClearML project by its name because I wanted to be able to plug in the name DevOps and find that project ID, because I needed the project ID in order to search for tasks within that project. And the reason I did that was so that I could look up all the projects in the DevOps project whose name was interactive session, because that's how you find the ClearML sessions. Except after the hackathon, I saw a note from the ClearML moderators in their public Slack workspace, and they actually had a suggestion, which I'll show you right now. They had a suggestion to simply query all tasks that are tagged with the interactive system tag. I wish I had known that during the hackathon, and it looks like I would have known that if I had just waited an hour or two after asking this question. But it's okay. We can potentially swap out the approach that I took for querying the interactive sessions with this approach later on, because I think this will be much cleaner and it will only require 1 API call instead of 2 to get the same information. Okay, so that was the heart of the work that Jordan and I did together, because Jordan and I did exploration of what the various ClearML endpoints are and how we can get this data off of them. So there was a lot of work figuring out how to auth with ClearML and how to hit it. And I was just about to show you that this ClearML REST API reference was very helpful to us during that process. For example, when we wanted to query tasks, it was fairly easy to find that here on the docs, on the sidebar, there is 1 list item per REST API resource for their API. So you can do API operations in the login category, the debug category, the projects category, the queues category, or various CRUD operations, or a subset of CRUD operations on the tasks resource. So we went to the tasks resource and we found that all of their endpoints are post endpoints, even though we're using them as get endpoints really, just to query information. But it also looked like if you do use the get verb on these endpoints, the request still went through. I wouldn't rely on that, but that was an interesting note. Okay, so we found an endpoint called get all tasks.getAll. And when we call this endpoint, we didn't get all the information that we needed. And so we ended up looking at our ClearML session page and using the network tab to actually monitor which API calls are being made whenever we visit this page here, because this page lists the sessions. And so this is a technique that we used not just here to list the sessions, but also to discover harder to access bits of information, like the stuff here on this info tab. Like, for example, the queue name and the project name were not returned when we called the tasks.getAll endpoint. So to show you how that worked real quickly, I go to the inspect, I right click on the page and click inspect, and then I go click on this network tab up here. And then if you refresh the page, you can see all of the requests that are made when this page is getting loaded. And a lot of those requests are these ClearML backend API requests. So check it out. It looks like they were calling an endpoint called tasks.get_all_ex. I'm assuming ex stands for extra, because what we learned is that the ex version of their endpoints, which are documented. So here I'll add _ex to my search query here. And you can see, I believe they take the same arguments. And so I think the ex is short for extra, because it seemed like when we called the _ex endpoints, a lot more information about the tasks was returned. So I think get_all without the ex is a type of endpoint that they actually have for all of their resources. And I think it's an endpoint that's supposed to return you a more minimal set of fields. Because I guess presumably when you're working with ClearML, you don't have to have all of the metadata that is available on a task object in order to work with it programmatically. In our case, stuff like the queue name and the project name for the task was only available if we called this endpoint. And we discovered that by doing this sleuthing here on the network tab. And if I click on this, you can see like here's some JSON that's returned by this endpoint. And by the way, this was another useful thing, just the fact that the docs were pretty good, but the fact that we could just come to this page and run the request and see an actual JSON example was really helpful when we were trying to figure out which endpoints to hit. Also, when I was debugging that error with Axios and finding out that it had unauthorized errors, I plugged my JWT token that I got from the authorization endpoint into jwt.io, and it told me that jwt.io was invalid. It told me that the token was invalid when I plugged it into jwt.io, so that misled me for a while. But then I plugged the same token into a Python request, and the request did go through in Python with the same token, so that was when I tried fetch and fixed that problem. But as part of that debugging process, I was able to come to the headers section of one of these requests, and I could see that the token was getting included in the request. And that's here in this cookie, if I'm not mistaken. Here it says Allegro token community. So yes, this looks like a JWT token. So I believe this is the JWT token. So that was our process of reverse engineering the REST API to figure out which API calls we needed to be making from the VS Code extension and how to make those API calls. Some of the information we still need to get are information about the resource that the task is running on. Like, for example, I don't think we currently are getting the information about CPU cores and GPU cores, or the available memory on the ClearML session. And this other stuff like platform would also be fantastic. And of course, it's great to have the queue name. So there's a lot of information here that is not yet displayed in the sidebar that we have. Okay, let's go back to the VS Code extension code. So what I've just shown you is the work that we did to create the API client and then to make requests to the API, which is great because that's the work that you need to do in order to get the data to show in the extension. So now that I've shown you how we get the data, now we need to have a discussion about how we got the sidebar to work to even display the data. And that was a whole part of the project that Jay and Saul and Paul helped with. If you notice, we don't actually have a separate icon for our ClearML extension because we never got far enough to figure that out. The best thing we could do is have it show up in the file extension. Well, I'm showing you the wrong window right now. Here's the window with the extension in it. But yes, if you look at the sidebar, there's not an extra ClearML icon. Anyway, so what we did is we made it show up in the File Explorer view, and this Node Dependencies icon is actually something that was from the Hello World tutorial on how to get one of these drop-down menus to appear. And these drop-down menus are called Explorer views, I'm pretty sure. And within an Explorer view, we created something called a tree view, which is basically a list of potentially collapsible list items. we disabled the collapsibility of the list items, and so we don't see little toggle drop downs by each of these. Anyway, so let me show you how we created these. If you Google TreeView API VS Code, the first thing that should come up is this documentation page showing you how to create a view just like this with collapsible list items. And they walk you through a tutorial how to do this, and there's a hello world example, which is the node dependencies example that I was just showing you here. And so Jay and Saul and Paul got started working on that, and we followed these directions, and I'll show you what it had us do. Basically, if you look at the package.json, we registered a command. If you look in the package.json, there's a section here called contributes. And under contributes, we added a section called views. And in views, we added a section called explorer. And I think explorer refers specifically to this file icon in the sidebar. So I think if we had chosen another term instead of explorer, and I think this is an enumerated type that you can find in the docs, then I think we could have hooked in our little drop down thing into a different one of these. They had an explanation of how to add your own icon to the sidebar, and we tried to follow it, and with the limited time we had, we didn't get it working. So we ended up just keeping it in the file browser. Okay, so we added this node dependencies one just for the sake of following the tutorial, and once we had it working, we added one for ClearML sessions, and we gave it an ID. Once we gave it an ID, we made a code change in our extension.TypeScript. So in our activate function, the tutorial had us copy paste in this code for the node dependencies. So this code down here is similar, and I'll explain this one instead of the node code. So we created something called a ClearML session tree data provider. So this is a class that we had to define, and I'll show you how that works in a second. The root path here is just the path on our file system to the root of this VS Code workspace. This is not an argument that all tree providers have to have, I'm pretty sure. So Jay and Saul and Paul got stuck on a problem where the root path was always undefined when they were following along with the node dependencies tutorial, which is sad because I think that only their hello world example needed root path just because that's how rendering node dependencies works. But I don't think that's actually going to end up being necessary for ours. So it's sad that that ended up being a problem because at the end of the day, it was a part of the hello world example that wasn't actually necessary for our app. But that's not something we could have known without getting it working because we didn't understand it until we got ours working. Anyway, so we created this tree data provider, and what that does is it provides tree data to a list. So ClearML sessions, I think this is called an Explorer view. That may be wrong, but the data inside of it is called a tree view, is called tree view data. So this is a tree view, and the data inside of it is tree view data. Anyway, so we registered our tree data provider with the ClearML sessions ID, so that which can then be referred to in the package.json, that's the part of the package.json that I just showed you. Later on, we registered an additional command called ClearML sessions.refresh entry, and it allows our provider to call this refresh endpoint, which what that does is it makes an API call to ClearML to query the sessions using the API client. And when it queries the sessions, depending on which sessions it gets back, it adds or removes list items from the tree view. So let's look at how a tree view actually works. It feels a lot like an algorithms and data structures problem from an algorithms and data structures class. Basically, you have a class that you need to create, which is supposed to extend from this VS Code concept called tree data provider, and this is meant to be a tree. Well, a tree is a set of nodes, just like if you've ever set up like a binary tree on like LeetCode or something. So in addition to defining a tree, you have to define what the nodes of your tree are going to be. So we called our nodes ClearML sessions. And so down at the bottom of this file, I'll collapse this class. Oh, I guess I can't easily. So down at the bottom of this file, we created another class called ClearML session, and this extends from tree item, which is basically their version of a node for the tree. So I think the easiest way to understand this file is to start from the tree item. So basically, a tree item is a node, and if you extend from tree item, there's only two values that you have to provide, and those values are, I believe, a label and a collapsible state. And look at this, when you call super, we pass in label and collapsible state. In addition to collecting these values in our constructor and passing them to the super method, we can also collect any other values in our constructor that we want, and then we can store that metadata on the class. Each of these tree items ends up becoming one of the list items in this list. And so one of the properties of the list item is label. Well, label actually ends up becoming the text right here, session ID. There's also more properties that you can set on this, like tooltip. And it happens to be the case that if you initialize a value called tooltip, which, it looks like I'm doing that twice, so this is unnecessary. But here I put some text into the tooltip attribute, and that makes it so if you hover over the list items, you see a tooltip, and this is the text in the tooltip with some IDs and other information that are specific to the session. This could be a lot prettier. All we've done so far is basically find out how to make a tooltip. We haven't figured out how to make it pretty or what information we should put in it. This is really just some test data. It also has something called collapsible state. This is an enumerated type that comes with the tree item class. It can be a collapsible state dot collapsed, expanded, or none. When these get created, we say that their collapsible state is none, and that's why they don't have a little collapse toggle arrow by them. If we set it to expanded, then it would show the toggle arrow facing down as though you had clicked on it and expanded it. And if you said collapse, then it would show it pointing to the right. So that's how you control which way the toggle arrow is pointing. Okay, so you can see here that in addition to collecting label and collapsible state, which are the only two required properties, I believe, of a tree item, we're also collecting version, which is unnecessary. This is a remnant from the node dependencies tutorial, so we need to remove that later. And we're also collecting depth, project ID, task ID, and comment. And except for depth, we're taking all the rest of these values and sticking it in the tooltip. So that's an example of how, like, look, you can put custom data on one of these nodes, and then you can use it however you want. I'll show you how depth is used in a second. The way the tree data provider works is when you register a tree data provider. The way a tree data provider works is there are two class methods that you have to implement. These are abstract methods. And one is get tree item and one is get children. I don't fully understand get tree item, but we took what the hello world example gave us, where it gives us an element and we just return the element. So presumably when the item is being rendered, maybe, I'm actually not sure when this gets called, you have the opportunity to like transform an element. I'm not sure what a use case for that would be. But the get children method was very useful. So here's how this works. Like, you can imagine a tree being an arbitrarily deep tree. So for example, here's my file tree here, and here's the node modules folder. If I click on node modules, there's all these folders inside of it. And each of these folders are list items that are also expandable. And if I click on those, they have their own children. Some of them are expandable, some aren't. If I click on the expandable ones, we get more and more and more all the way down. So it's theoretically, this tree structure supports theoretically infinitely deep recursive trees. And you have to think that when I click on this node modules folder, some amount of code must be being executed to then list what the children files and folders of this are to then display them here. So when I click on this tree item here, this node modules tree item, some amount of logic is done using the tree item that I clicked on as input to then discover what the children should be. So that is the point of get children. Basically, the get children item is clicked on every time you expand a tree item. So the way this works is an element gets passed into this function, and that element is the tree item that you clicked on. This function should then return elements that would be the children of the element that got passed in. And whatever elements you return, those will end up as list items nested under the one that you've clicked. So the way we did this is, if you click on an element, the way we used this doesn't take advantage of this infinitely. The way we used this doesn't actually use this support that the tree view has for infinitely deep recursive trees. We only needed one layer deep of our tree because we're really just trying to display a menu with only a top level. So here is how we did that. When you first open one of these tree view items, an element actually gets passed in, and it's an undefined element. So whatever you want to show up at your top level, you have to make it so that whenever undefined gets passed into this list, then you return the elements that you want to have at the top level. So that's what this if not element thing is about. If the element that was passed into the function is undefined, that means you just barely opened up this Explorer view. And so whatever you return should be that top level list. And so what we do is we just basically use this .map function to loop over all of the interactive sessions that we've queried, and then call new ClearML session on each of the sessions that we queried and create one passing in information about the session. Once these tree items are returned, they show up in the list. And so if the tooltip property is available on them, then you can hover over and see the tooltip property. If the label property is set, then you can see that as the title here. And I think this grayed out property is called description, but I could be wrong. We made it so that if the element is defined, so for example, when I click on one of these ClearML sessions, that element then gets passed into getChildren, and we just return a promise of an empty list, which is to say this thing has no children. Also notice that I passed in vscode.treeitemCollapsibleState.none, and so this is where I made it so that the state is, so that there is no collapsible state or no toggle item on these list items. Okay, I made it so that the tree provider class here has a property called interactive sessions, and I gave it a refresh method that calls this fetch interactive sessions function, which does all the work of reading the Hackathon ClearML conf file and querying the latest list of sessions. It might not be the most optimal thing to query the ClearML conf file every time this refreshes, but it was simple for me to implement, and I guess one benefit of this is it's technically a very pure function, so that's good. I also don't know that it's the best that the ClearML sessions tree data provider is the only place in our program that we have our list of interactive sessions. It might be that we want to maybe store this list somewhere else and maybe pass that into the refresh function or something like that. Or maybe the refresh function doesn't even belong in here. Or maybe the refresh function doesn't even belong on this class. But suffice it to say, this is how I've implemented it so far. We store all the interactive sessions as a class attribute, which gets refreshed every time this refresh endpoint gets called. And that does the entire process of reading the config file and fetching those from the ClearML backend. And once those are there, then we have a non-empty list to use when this getChildren function gets called. And so we can display that in the tree view. Okay, the last thing to show you is, all right, I have two last things to show you. One is that I created a folder called models, and in models, I made a single folder called tasks. And this is a folder for interfaces for the task object. The task object of a ClearML task can have a lot of metadata on it. This task refers to the metadata that you get in response from the get all tasks endpoint on ClearML. There's so many fields in that JSON object that I figured it made sense to create an object so that when you're coding, it's easier for you to discover which attributes you have available to you. I haven't done extensive work into double checking that these fields are guaranteed to be present when you make a query request. I just took a single example request and then turned that into a type interface. So I would not have high confidence that all these fields are always present whenever you make one of these requests. I created a command called refresh entry, which calls the refresh method that I just showed you on our instance of ClearML sessions tree provider. And now that I've shown you the data provider that we've registered and this refresh command that we've registered, you might be wondering how we got the refresh button to show up here on the ClearML sessions item. That actually was quite hard for us to do. The way we got that to work was by extending the package.json again. And to be honest, I don't remember all the things that we did, but I remember there was a lot of fiddling with this file. So clearly, even just understanding this file deeply is an area that we would love to have a contribution in. But we did register a command. We registered the ClearML sessions refresh entry command. So you can run this command directly here from the command palette. But we also added a section to menus under view/title. And the choice of what you put here is also very particular. Depending on what value you set here, a button or menu item might appear not on the top of this explorer, but they can show up in a lot of different places. So in this view/title, we added the refresh entry button for the node dependencies tutorial as well as for our refresh entry command. And group navigation also influences where the button shows up, and it wasn't super clear to me what the interplay between group and this choice is here. And when also determines when it shows up. I think you can set conditions to make it so that the button doesn't always show up here, or that maybe the button can show up on every single list item or something like that. Something really interesting to note is that the refresh button obviously has this refresh icon, and we got that refresh icon from a set of open source icons that come in a pack to make it easier to develop VS Code extensions. You can Google VS Code extension icons and you'll find the full index of icons. So from there, you can grab any icons you could want to make UI elements for a VS Code extension that are consistent with the general VS Code style guide. Okay, so we created a resources folder in the root of our project filled with these icons. We have a folder called dark and a folder called light and one called package explorer PNG. I can delete this right now. The reason I had that extra file and all of these icons is because we actually copied and pasted this resources folder from the open source VS Code sample extension project. So that's where we grabbed these. We put almost no thought into these other ones. We just grabbed the resources folder because we needed the refresh icon, which you can see as an SVG file. So it looks like, so it's XML. Okay, so I showed you that, and I want to show you that the place that you associate the refresh button with your menu item is actually not in the menu itself. You put the association with the icon actually with the command itself. So when we register this attach session command, we stick a path to the icon on that, which I thought was kind of weird. But then later on in the menu, when we reference the command, I guess that menu reference then turns around and looks up the icon reference, both for light and dark mode. And so that explains why this gets here. And so I think what's interesting is like, maybe I'm not sure about this, but maybe if you did that and put that command here on the sidebar, that's how you would get the refresh icon on the sidebar. So I guess maybe it makes sense to put icons with commands, because then wherever you register them, whether it be down in the tray or the sidebar or in tree view items, like all locations can have the same icon. And there's not a location specific way of registering icons. All right, the last functionality to show you is right-clicking on a list item. You get this context menu, I think is what it's called, with two different options. One is view in browser, which takes us to the ClearML UI in the browser with a specially crafted URL to take us right to the interactive session. I thought that was pretty cool. It was actually really simple to implement. So because it's so easy to explain, I'll just show you how I did it. If you come to the extension.ts, you can see that I registered a command called open in browser, and I also registered this in the package.json file. And the way that I got it to show up in the context menu also has to do with where I put it in the package.json file. But basically, I registered with this command a function, and I made it so that this function accepts an argument. And I found out that the argument is actually the tree item in this tree. And so all of the information about our tree item is here on the session. And in fact, I should probably just make that a type annotation here, ClearML session. To do that, I'll have to export this class, which I can't do because this class is actually a nested class. That's not true. Okay. All right, good. Now I can add the type annotation to these session objects. Cool. That should be helpful. Anyway, so this should make it very, very clear and concrete that it's the actual tree item that gets passed into this handler function whenever we run these commands that get triggered specifically when we call them from the context menu. So I guess if we were to call these from the command palette, I don't know that we'd be able to associate it with like all the data that we get from the tree view items. So that's an interesting thing to note. Anyway, it turns out that once we have the session object, it's really easy to open up the window in our browser. I basically crafted this URL and plugged in the session project ID and the session task ID there. And then I called vscode.env.openExternal and then did this to turn our URL into this parsed VS Code URI object. And by the way, where I learned to do this from Stack Overflow. Cool. So that's how that context menu command works. The other one here is attached to session, and this is not complete, but I just ran the command. So I'll show you how far I got on it and what my thinking was here. If you click on the output console, we can look at the logs for ClearML Session Manager, and you can see we have some logs that have to do with starting to create a ClearML session, attaching to an existing session. Let me show you what code this is actually running so you can see what I was trying to do. Basically, these three lines can be ignored, except this line should be the path to our Python interpreter. So then I made a command for running bash commands. I made a function for running bash commands. You pass the command in as this argument, and then you pass the arguments in for that command afterwards. So the command is going to be basically a long path to our Python interpreter. And then I do -m and then ClearML_session. So this will make sure that whichever version of the ClearML session CLI that we've installed in this Python virtual environment will be executed. And then we pass the --attach argument to that and the session task ID. So what this does is it runs ClearML session attach to this ClearML session task ID that we clicked on in the context menu. And it does that using the version of ClearML session installed in the currently active Python virtual environment, which you can find whenever you open up a Python file and look down here. My thinking here is that this would allow us to run the sub process without blocking without blocking TypeScript, or better said, without blocking the node runtime as a side process. Because what this command is supposed to do is it's supposed to start an SSH. It's supposed to open an SSH tunnel from your machine to the ClearML session. And that tunnel is going to have to stay open for as long as you're developing. So it's not meant to run and then end. It's meant to actually run for a long time in parallel with you using VS Code connected to the session. So actually running the command does work. We can actually run this command and start opening the session. I'm not sure why we're not seeing any logs past this though, so maybe that means we've broken. But actually right here we can see the IP address. So actually I think the tunnel might just be open now with the session that's currently running on our AWS EC2 instance. Maybe that's true. If it is true, then the way that I would connect to it is by triggering the remote SSH connect to host command and then passing in SSH root at localhost 8898. Because when we open the tunnel, localhost port 8898 will actually map us through the tunnel into the EC2 instance. So let's try running that. Okay, this failed, so I'm not sure why. So this is a whole area to debug, but what I just showed you is what we're trying to achieve. Also note that the SSH password is right here in the logs because ClearML fetches that for us. We should find a way to be able to parse these logs and grab this password out so we can do two things. One, I want to automatically, whenever the tunnel is opened, trigger this remote SSH connect to host command and then plug in whatever information is needed here. And assuming this runs successfully, then we're going to be asked for our password. It'd be nice if we could automatically actually plug that in so the user doesn't have to. Or if the user does have to, then it'd be nice to just put it in their clipboard so they can just paste it in instantaneously. So that would take the effort away from the user of like finding the exact password for this. And it would also mean that these really long, randomly generated, very secure passwords can still be conveniently used, which I think would be a really good quality of life improvement for using ClearML sessions. If you want to play with the UI inside of our repository, we have a folder called ClearML Playground, and Jordan and I played around in some Jupyter notebooks. And in these Jupyter notebooks, you can see examples of us using the curl command to hit the ClearML API, as well as using the Python SDK and using the requests library to make requests to the ClearML backend API. So if I were playing around with making authenticated calls to the ClearML API, I would probably come here and do that. I want to end the video now, but before I do that, I should probably answer the question of like, what's next? Like what things do we want to add so that this is finished or just really nice to use? Well, one is that obviously this is not published on the VS Code extension marketplace. So that would be a whole thing to figure out, is how to make a CI/CD pipeline that, like, hopefully by clicking the pipeline can release a version of this that either automatically or makes it very easy to publish our extension to the VS Code marketplace. We may have to like sign up for an account or something to do that. We also need to figure out how to make a real sidebar extension, not just adding our ClearML dropdown list to the file explorer sidebar. So that may not actually be complicated, but we didn't put in the time to figure that out at the hackathon. It would also be great if when we click on these things, we can easily see all the information about the session. And that could potentially be done by just making tree items underneath each of these, where the tree items are the various metadata fields of the session. That could totally work. It would also be cool to have a little plus button up here, which somehow opens up a wizard with a form with fields that you can fill out to start up a ClearML session. So right now we have no ability to start ClearML sessions, so that's a whole thing to add. We also should make it so that attaching to ClearML sessions actually works. So we need to debug this. We need to make it so that maybe there's a button on each of these sessions to instantly connect to them. Maybe we could have it would be nice if instead of using a context menu like this with items like attached to session and view in browser, it'd be cool if we could actually make those as buttons, like maybe a globe icon for view in browser and maybe a plug icon to actually trigger the remote VS Code connection to actually connect. And if the tooltip can be made prettier or more useful, if you have any ideas for that, maybe we could make the tooltip better as well. But all this data that I added in the tooltip, maybe that actually just belongs as tree items underneath each of these sessions. Besides this, we have it would be nice to link to documentation or write our own documentation for how you can start using ClearML with ClearML sessions. Like maybe we should show people the process that we went through to create an EC2 instance and install the ClearML agent using the ClearML SaaS offering. Or maybe we could harden another open source project that I have where we use AWS CDK to self-host our own ClearML control plane on AWS. Or maybe the most easy thing to do, but also high impact, would just be show people how to run ClearML in Docker Compose on their own machine and set up an agent. That could actually be really great for us for a development environment for the ClearML extension. Like right now, the ClearML session that we have is running on an EC2 instance in an AWS account that I have control of, but I don't know that we'd want to open that up. I don't even think we need to open that up, that AWS account, to all contributors. So actually, I think it would make it very easy for contributors to develop on this extension if we just had a Docker Compose that the contributors could use to start up sessions. So getting a nice Docker Compose file for our repository and documenting how to run that file and then point your extension at it, that could be a really good thing to do as well. Also, the whole thing I showed about parsing the Hackathon file with TypeScript, right now I'm just using regular expressions to do that. It would be awesome if we had a much more robust and reliable way to parse that file. As far as the life of this project, I think you can make, because the project is so young, there's so many ways, like all the ways I just listed, that you could make a really impactful contribution. And what's exciting about this project is it's impactful in general. Like this can make data scientists all over the world have better access to remote workstations. And not only that, they can do it potentially for free. Like you could do it on your own gaming PC if you wanted to, which is very cool. But it's also part of this enterprise-oriented tool, ClearML, which is well used. And so it's definitely the kind of contribution that you can put on your resume too. And do we need to make the best VS Code extension in the world? Maybe not. Honestly, like you could think of this extension as a POC. And so this extension that we write might not be the ClearML extension that ends up living long term. And that's actually very okay. Like you could think of a potential exit strategy, so to speak, of this small open source project as maybe we prove that these things can be done and we show that they can be done well using an extension. And maybe our code's not exactly the best, although I'd sure love to make our code practices good. But maybe after showing that the extension can work by building it out fairly well, the ClearML project actually just adopts it to make it a first-party ClearML product instead of a third-party ClearML product. As far as contributing goes, that's a pretty compelling story for a resume or for just generally building your own street cred in the DevOps or MLOps community. And, if that means that they have more resources and the project can live on, that's potentially better for you because it means that you may not necessarily be called on forever to be maintaining this extension. This is something that you can do now and then someone else can pick up and you can still get a lot of credit for it. And so there will be open source glory for you now and later. And, if it's an open source project later, it's still true that the people maintaining the project get glory and credit for that as well. So yeah, I guess my point is this project can be very impactful now and can continue to be impactful without forcing you to commit to making contributions to this project for the rest of your career or something like that. This is also something that I can easily see myself using, and I can imagine you using it as well for training models, maybe using your own hardware, or just making it easier to access hardware in AWS or some other cloud provider. Oh, this is something I didn't mention, but we have no tests for this repository. I've never written tests for a TypeScript project before. And so let alone tests for a UI-based project like a VS Code extension. So that's also a whole area that we could use some guidance in. So yeah, lots of room for impact. And since it's so young, lots of room for creativity too, since it's not very established. All right, great. Thanks for watching as much of this video as you did. I will make sure that I publish all of this code on GitHub and you can review the project from there. And now I'm appending one last note to this video for historical purposes. But one thing we discovered is that when you start up a ClearML session, that session starts up an SSH server inside of it. And that SSH server actually mounts by default the SSH keys of the host EC2 instance into the ClearML session. And we had started, and I believe that the keys that it hosts, that it mounts into the container are not the keys that you find at home SSH. Well, they are, but actually before the container starts up, I think that the ClearML agent actually copies tilde.ssh to a temporary .ssh folder and file path. And it's that temporary version of the SSH credentials that gets mounted into the running ClearML sessions. And that's really important because an error that I ran into is that I have a key pair in AWS called Eric Riddock, and it has a public key. It has my public key associated with it. And so in my SSH folder on my laptop, I have the private key that goes with that public key. And it turned out that was breaking connection to the ClearML sessions only for me. So there's two fixes to that. One is I could just move my .ssh folder somewhere else, like maybe .ssh.bak or something, and that would allow me to use a different key than the one that's mounted into the EC2 instance. Into the ClearML session, which allows me to get in. Or in the ClearML session, in the session on startup, in a non-startup script, you could have a command that moves your .ssh folder somewhere else, so that the ClearML session is not using the same SSH keys as I had in the EC2 instance. The reason why on an EC2 instance that this was a problem is that the public key in this key pair called Eric Riddock has a rule inside of it. So it gets added to an authorized keys file. And that authorized keys file is written for EC2 instances. And what it says is that you should never SSH into an EC2 instance as the root user. You should only ever log in as the EC2 user. So the host EC2 instance is listening on port 22, but the ClearML session is listening on some other port like 10.0.0.22. And when you try to SSH in at root of the public IP address of the ClearML session at 1.0.0.22, a rule inside of the ClearML session container actually gets taken from the mounted authorized keys file, which says to reject incoming connections if you're connecting on root, and instead connect as the EC2 user. So that's a rule that EC2 instances generally have. EC2 instances generally stop you from logging in as root. They want you to log in as the EC2 user. But when you log into a ClearML session, you have to log in as root. And since that ClearML session has picked up this rule to reject things that log in as root, you can never log in. And so some way you have to move that authorized keys file that has that rejected rule. And it only happens if you're using the private key that's associated with the key pair of the EC2 instance, and in which case I was, because I was lazy and made it so my Eric Riddock key was associated with the instance. Hopefully that made sense. If it didn't, this will be enough for it to make sense to me, and so I can debug the problem if it comes up again. Okay, bye.